Hello, in this video we will be reviewing how to find the area between curves. Alright, area between curves. What that means is, let's say you have two curves like this. What the area between the curves is just this area. So, a simple way to just understand or visualize how to solve these problems is if you have, let's just redraw that. If you have a graph like this, and you're trying to find that area here, you can just set up these intervals, and if you were to find the area under this curve, it would look like this, right? But that's too big. So then, if we subtract the area under the bottom curve, that would just get rid of this extra stuff, and all we're left with is the good stuff. Alright, so how do we write this out? Well, we know that the area under a curve is using the integral. So if we have, let's just say this is f of x, the top one is f of x, and the bottom one's g of x. And then the intervals from a to b, then it's just a to b of the top one, which is f of x, minus g of x dx. So that would just be the area under the top curve minus the area under the lower curve in the interval from a to b. And if you're not going to draw a graph, then you won't really know which one's higher and which one's lower. So then you can just do the absolute value, and then it will always be what's inside. But I recommend drawing a graph, because then you'll see what's inside. Okay, our first problem is going to be very simple. So let's say we have f of x is equal to x squared minus 4. And then we have g of x is equal to x minus 2. So all we have to do is find the area between these curves. So first, let's graph this. So x squared minus 4 would be 4 down. And then x squared is just like that. And then if we have x minus 2, it would be like this. And then our area between the curve, which is what we're trying to find, will just be like this. So if we remember our formula, it's the area under the higher curve with the bigger value, and then minus the curve with the lower value. So if we have our intervals here and here, first we would take the area under this big curve. So our higher value would be x minus 2, and then subtract the value of the lower curve, which is x squared minus 4. So now we have to find our intervals to set up the integral. So how do we do that? Well, they intersect when the two equations equal each other. So if we set them equal, x squared minus 4 equals x minus 2, we can set this up into a quadratic equation and then solve from there. So x squared minus x minus 2 is equal to 0, which is just x minus 2 times x plus 1. So they intersect at negative 1 and 2. So then we can set our interval as negative 1 to 2. And now that we have our intervals, we can just take the higher value minus the lower value. And it is helpful to write out parentheses so that you know which one to put the negative sign for. So we do x minus 2 minus x squared minus 4 dx. So now you have your integral, and you can plug it into your calculator, or if you don't have a calculator, you can solve it with the antiderivatives from there. But with the calculator, you just plug it in and you'll get 9 over 2. So that means that the area, this green area, is 9 over 2. or to be exact, 9 over 2 units squared. Okay, so our first problem dealt with equations that were in terms of x. So that's like x squared. But what if we had something like y squared? Then all we would have to do is just solve it in terms of y. So an example problem would be x is equal to y squared minus y minus 6, and x equals 2y plus 4. So we have to find the area between these two curves. So the graph would look something like this. Obviously, it's not going to be drawn to scale, but it would look something like this. And then 2y plus 4 equals will look like something like this. So our area will be in the green, so we have to find this area. So remember how when we were solving for x, we would find the intervals and then do the higher one minus the lower one? Well, that wouldn't work here, because then we would get this area, and it wouldn't be good. So what we would have to do is find it horizontally. So if we find the interval here, instead of going down on the x-axis, we do it with the y-axis, like this. And same here. So now, the higher value would be this one, minus the lower value, which is this one. And then that would leave us with the green. So then, what that would mean is our higher one is 2y plus 4, and the lower one is y squared minus y minus 6. So to find our intervals, again, we set them equal to each other. So we have y squared minus y minus 6 is equal to 2y plus 4. And then we have y squared minus 3y minus 10 is equal to 0. And then to factor out, we get y minus 5 times y plus 2. So then our interval will be from -2 to 5. So now we can set up our integral equation. So that would be -2 to 5 of our higher one, which is 2y plus 4, and then subtract the lower one, y squared minus y minus 6, dy. Keep in mind it's dy because we're going this way now, because we have it in y. So again, now you can plug it into your calculator, and the final answer is 343 over 6 units squared. Okay, finally we will do some key tips. So the most important tip I have for you is to draw a graph. A graph just makes it so much easier to see what's going on and to see what's higher and lower. And it will make it a lot harder to make simple mistakes. Second, you should use absolute value if you can't draw a graph, because no matter what, if you use absolute value, you will always get the correct value. And third, remember when we had multiple intervals, we had to split it up into 3. So yeah, if you draw a graph and it changes into multiple intervals, then just split up the graph. Thank you.